Welcome back. Today we're going to go over 10.2, Exploring Chord Properties. And so we're just going to talk a little bit about the different terminology that we need to know to be able to do this next section. So a couple terms that we will need to know is the word perpendicular, which means 90 degrees. So if something's perpendicular, that means it's at 90 degrees. So it's indicated by usually a little square like this. Okay. Bisector, which you'll see up here, bisector just means cut in half. So if something is bisected, that means it's cut directly in half. And so you'll see that to show that, let's say we have a line here, if they want to show us that it's bisected, cut exactly in half, they'll indicate usually with lines like this, or even just one dash on each side that shows you that this side is exactly the same length as this side. Okay, and then we're going to put those words together: perpendicular, bisector. So if we look at our definition here, perpendicular bisector of a chord is a line that passes through the center of the circle and is perpendicular to a chord, bisects the chord. Okay, so a perpendicular bisector is a line that cuts a chord directly in half at 90 degrees. So bisector means cut directly in half, and perpendicular means 90 degrees. And so if these two things happen, then that means it passes through the center of a circle. Okay, so sometimes basically they'll give you 2 out of 3 of those conditions and then ask you to solve a question based around that. Okay, so let's just erase this here quickly. So let's look at our first example. It says radius CD bisects chord AB in this diagram that we have here. Okay, chord AB measures 8 centimeters. The radius of the circle is 5 centimeters. What is the length of line segment CE? So again, they're referring to lines by the letters they join, and we have some dimensions here. So let's redraw this as best we can with the dimensions added. Alright, so let's add some dimensions here. It says chord AB measures 8 centimeters. So this entire chord across measures 8. So because of these two lines here, we know that each side measures 4. And I'm just going to leave out the centimeters just so it doesn't get too cluttered, but we know that every dimension we write is going to be centimeters. Okay, so it measures 8, therefore both sides measure 4. The radius of the circle is 5 centimeters. So the radius would be CD, right? This entire radius is 5 centimeters. Okay, so CD is 5 centimeters. The entire thing, though, is 5 centimeters. What is the length of line segment CE? Okay, so let's see if we can figure this out. So a lot of the time, you're going to have to use Pythagorean, right? Which is a squared plus b squared equals c squared. And that's for any right triangle, right? We've seen that a lot before. So if we have a right triangle, A and B are the sides, C is the hypotenuse, and then this formula will hold true. So we're going to have to use that. But it's not obvious yet how we're going to do that, because we actually have to find this side, right? And so let's see what we know here. Notice how it doesn't show us in the original question. It doesn't show us that it's a 90-degree triangle. Okay, so first we have to sort of prove that it is. And so if we look back at the rules, radius, it bisects the chord and it goes through the center of the circle. So if 2 out of those 3 things hold true, then that means with a 100% certainty we can say that this is a right triangle. Okay, so we're so close. Now the other sort of, not trick part, but the thing we have to keep in mind is it says the radius is 5 centimeters. So that's any radius. So if we were to go here, 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 anywhere from the center of the circle to the outside is exactly 5 centimeters. So the thing we maybe didn't see immediately is that AC is also a radius. So that means this is also 5 centimeters. Okay, so we actually don't need this 5 centimeters here is not going to help us that much, right? We have no idea, because it's not a bisector. There's no indication that the top part is the same length as the bottom part, so that actually doesn't help us at all. The radius that we needed to notice was the hypotenuse of that triangle. Okay, so now we see that we can use Pythagorean theorem. So we'll say, if we use our actual numbers for this question, so x squared plus 4 squared equals 5 squared. So x squared equals, we'll go 25 minus 16. X squared gives us 9. And if we square root, we get x is equal to 3 centimeters. So now we can say that x on this side here is 3 centimeters. Okay, so how we did this, quick review. We know that because it told us that it was a perpendicular bisector, it didn't tell us that, sorry, it told us that it bisected the chord, and we saw that it went through the center. So because of that, we know that it's 90 degrees. Okay, 2 out of the 3 conditions were met, so we could assume the third one. Then we labeled the things we know because it bisected the chord, and they told us it was 8 centimeters. That means this side would be 4. It also told us the radius was 5 centimeters, so the radius is here is 5. And because we know it's 90 degrees, we could solve for our 3 centimeter missing side. Okay, so these questions are basically just fancy ways of using Pythagorean theorem and understanding how circle geometry works. Okay, let's try another one. So it says radius CH bisects chord FG. So this is almost the same question. The radius of the circle measures 10 centimeters. What is the length of CJ? So I'm just going to draw it bigger here, 1 second. Alright, so let's just label what we know. So on your page, you don't have to sketch it perfectly, but I would draw it so that you can actually write in the lengths that you can see, and then it'll be a little more obvious which ones you have to solve for, just like what I'm doing here. So CH bisects the chord, so it's referring to this, I'm sorry, not perfectly calibrated here, we're referring to this line as the radius, but remember, anything from the center to the outside is the radius. So both of those radii are exactly the same length. So let's see if we can figure this out. Chord FG measures 12 centimeters, so all the way across. So again, I'm going to use half of that because they're bisected. So both of these sides would be 6 centimeters. The radius is 10, so HC is 10, but actually this 10 is the one that's going to be more useful to us because we don't know how long these sides are. And we're trying to find CJ, so we're trying to find this. I'm going to label this X, this distance here. And we know it passes through the center, and it's bisected, right? We see those lines, so we know it has to be perpendicular. So this has to be 90 degrees. If I can draw a little square here, that would be helpful. So this has to be 90-degree angle. Okay, so same thing, we can use Pythagorean. So let's just review here. The hypotenuse is the only one that matters that much. So this is c squared, right? The other two don't necessarily matter which one is which. So I'll go x squared, that's just what I label that side, plus 6 squared equals 10 squared. So then we'll solve that. X squared plus 36 equals 100. Minus that to the other side, so x squared is 64, and then we have to take the square root. X is 8 centimeters. So does that look reasonable? Let's look back at our question here. If this was 6 and this is 10, does it make sense that this would be 8? In our drawing, the way I drew it, it looks a little bit shorter, but if we sketch it or look back to the original one, yes, CJ looks like it is actually a little bit longer. All right, there we go. So let's move on and let's try one quick question here. So we can actually use these chord properties to solve a problem. So it says Louise would like to drill a hole in the center of a circular table in order to insert an umbrella. So she wants to put an umbrella in here somewhere. Okay, she used a diagram to explain how she could locate the center. So the solution is actually given to us here because I didn't want to draw it inaccurately. So the solution would be you draw two chords. Okay, so we'll kind of go over it as we read the solution. So if we have our table, okay, the solution would be to draw two chords. So any two chords. Let's say here, we'll actually do it similar to what they did. So they went here and here. It doesn't really matter what they look like. Okay, locate the midpoint of each chord. So it's not possible to sort of measure a circle, like with measuring tape, for example. But if this was your table, you could measure the length of each of those chords. So let's say you measured them, and then you found the exact center of those chords. So you measured them, oops, and we found the exact center. Okay, so we're bisecting them. Now it says, draw the perpendicular bisectors of each chord. Okay, so right at this center point here that we found, right at this center point, we're going to draw the bisector. So we're going to measure with a tool 90 degrees, and we're going to draw a perpendicular bisector. So it's not here, right? We're measuring, and we get exactly 90 degrees. I'm just going to use a different color here. So let's say we measure, here's a bisector. I'm going to go way past it just to be safe. And then I take this other chord, okay, and we bisected it. So what that means is that we carefully measured that this was 90 degrees, this was 90 degrees on both sides of those. And this side is the same length as this side. Okay? The point of intersection is at the center of the table. So that is what we aim to find. So it's actually somewhat complicated to just find the center of a table or a center of a round object without doing a little bit of measuring, but all we had to do was measure the length of these chords, cut them in half, sketch a bisector perpendicular, and then that center point is where they cross. So there's a couple questions like that where you might just have to describe or draw a little diagram. You don't have to measure perfectly when it asks you to draw them, but just to understand that that's how the questions where you're trying to find the center, that's how it works. Okay, so let's just go over these key ideas here quickly, and then we'll try one more question. So the perpendicular bisector of a chord passes through the center of the circle. So that's what we needed in that last question, right? If we have the perpendicular bisector of a chord, it goes through the center. The perpendicular bisectors of two distinct chords intersect at the center, right? Because they're each going to go through the center, so the point that they're each going to cross will be the center. That sounds kind of obvious, but if you draw two chords and draw their perpendicular bisectors, they're both going to end up at the center, so the point of intersection where they cross, like in that last question here, is the center of the circle. Okay, and that will hold true for anything. You only need two chords, but I could have drawn a third one here, found the perpendicular bisector, drawn it through the center, and you'll notice that it'll go through that same spot as well. Okay, that works for any number of chords. If a bisector of a chord in a circle passes through the center, then the bisector is perpendicular. Okay, so just to flip back, in this question, we knew they were perpendicular because it told us to draw it, right? Whereas in the last question, we didn't know if it was perpendicular, but we could figure that out because we knew it passed through the center and it bisected the chord. So do you see how these conditions to be able to do a question, you need 2 out of 3 of them to prove the third one. So this one was if a bisector sector of a chord in a circle passes through the center. So if it goes through the center, then it must be perpendicular. If a line passes through the center of the circle and intersects a chord at right angles, then that means it cut it also directly in half. It bisected it. And then the last one is the shortest path between the center of the circle and a chord is a line that's perpendicular to that chord, which makes sense, right? If we want to draw the shortest line from the center to the middle of a chord, we're not going to draw like some weird line, right? We're just going to go straight down, which would make it perpendicular. Okay, so the things to remember from this slide is that basically if two conditions are met, then the third is true. And so the three conditions are: it's perpendicular, it bisects, which means cuts in half, and it goes through the center of the circle. Right? So if two of those things are true, then the third one is also true. So if it's a perpendicular bisector, that means it must go through the center of the circle. If we know it cut it directly in half and went through the center of the circle, then we know it must be perpendicular. Okay? And honestly, with a lot of these questions, they're not trying to trick you, but eventually you might see one where they only give you one and your answer is that you actually can't prove it. Okay, let's try. This is actually the first one off your assignment. Number 4. It says CD bisects the chord AB. The radius of the circle is 15 centimeters long. Chord AB measures 24 centimeters. What is the length of CE? So we'll just try and do it on this circle here. So we're trying to find what is the length of CE. So we're going to put an X here. That's the length we're trying to find. What else do we know? We know that the radius is 15 centimeters long. So there's a couple radii here, but the one that's going to help us is this one. That's 15 centimeters long. CD is also 15 centimeters, but that's not going to help us because we don't know how long that is. Sometimes it might, right? If they told us this distance here, it might help us out. But in this case, that radius is not going to give us any information we need. Chord AB measures 24 centimeters, so all the way across, and we can see right now that it bisects it. So I'm just going to write 12, right? Because they're each going to be 12 because the whole thing's 24. What's the length of CE? So now, how do we prove it's a right triangle? Because it needs to be a right triangle in order to solve for x, right? If it's not a right triangle, you can't use Pythagorean. So it goes through the center, right? Check. And it bisects the chord AB. So the line CD is the one I'm talking about. It goes through the center of the circle and it cuts that chord directly in half. Therefore, it's a perpendicular bisector. Okay, that's what I was talking about in the last slide. So it went through the center of the circle, it bisected the chord, therefore it's perpendicular. Okay, and when it's perpendicular, then we can easily use Pythagorean. So which side is our hypotenuse? That's the one that we need to keep straight. This one. So 15 is the hypotenuse. So we're going to go and we'll write a squared plus b squared is c squared, and c squared is the hypotenuse. The other ones don't matter. So I like to go, might as well just do x squared first. X squared plus 12 squared equals 15 squared. So x squared plus 144 equals 225. And then we'll minus 144 to both sides. And I get x squared equals 81. And they might not always be perfect squares. You might end up with a decimal once in a while, which is okay. Just leave it to one decimal place. But we'll see that this is actually a perfect square. So it ends up being 9. And then let's just double check our units. These were all in centimeters, so x is 9 centimeters. And does that make sense? If we had here 9, 12, and 15, remember the hypotenuse should always be the longest one. So that seems like a reasonable answer. All right, so I'll post these notes on the website, as well as the assignment for 10.2. So give it a try. Again, let me know if you have any questions, and then towards the end of the week, I will answer those questions in a separate video. All right, good luck.